Okay guys, so now let us take one numerical, very interesting, very beautiful numerical based upon the non-uniform cross-section. Okay, so what the question is, we have a wire of non-uniform cross-section, so we are given a diameter d1 which is equal to 1 mm. Not area, it's a diameter. L1 Mika, right? Pay attention. It's a diameter, not area. Means this part is given, diameter is given, not area. Right? And likewise, the diameter of other side is given, right? Let me take this as d2 and that is equal to 2 mm. We are given diameter, not area. Right? Okay? So diameter, d1 and d2, they are diameter. This is 1 millimeter and that is 2 millimeter, right? And suppose this is area A1 and this is area A2, area of cross-section. This is cross-sectional area A1 and this is cross-sectional area. This is the area, right? A2, right? So we are given a current. Suppose at this point the current is I, right? I1 is equal to 1.2 ampere, right? L1 1.2 ampere, right? And drift speed at this point V1, drift speed, or you can write it as VD1, right? Because I am considering this point as 1 and this point as 2, right? So drift speed at point 1, so VD1, that is equal to 2.2 multiply 10 to power minus 4 meter per second. L1, am I right or not? 2.2 multiply 10 to power minus 4 meters per second, right? So find out the current and drift speed at point 2. This is the question, right? So what we have to find? We have to find I2, current at point 2, and we have to find drift speed at point 2. So these two things we have to calculate, right? So let me change this diameter into radius and then from the radius into the area, right? So if we calculate the area, so what is the radius? Radius, that will be equal to half of the diameter, so that will be equal to 0.5 mm, right? So I can write R1 is equal to 0.5 multiply 10 to power minus 3 meter, because I have to change in meter. Likewise, I can convert R2 is equal to simple, right? If diameter is 2, radius will be 1. Very easy, 1 millimeter, and 1 millimeter is equal to 10 to power minus 3 meter. So R2 is known, R1 is also known. Now we can find out the area, right? So A1, right? So let me write here. If we know so we can find A1. A1 is equal to pi R1 square. A2 will be equal to pi R2 square. Okay, so if I calculate pi R square, pi R1 square, so what is this pi? Pi means 3.14, right? R1 square means 0.5 multiply 0.5 and this will be 10 to power minus 6, 10 to power minus 6, right or not? Okay, and this becomes 3.14 into R2. R2 is 10 to power minus 3. 10 to power minus 3 square means 10 to power minus 6. Okay, so now you see current at this point is I1, and we know because of the conservation of charge, the current at this point, that means I2, that will also be equal to 1.2 ampere. So the first question is solved, right? To find the current, that's so easy because conservation of charge. But to find VD2, that is a little bit complicated task. So to find VD2, I have to correlate the formula at A1 and the formula at A2, right? So if I check, so what is this I1, right? So this I1, that will be equal to NaEVD1, right? and I2 is equal to NA, this is A1, this is A2, EVD2. So you see, N is constant, so I will not use this because the density everywhere is number density is same. Charge on the electron, that is also same. So I will not take Ne. Likewise, I will not take this N and this E. Right? So what is left? I1 is equal to A1 into VD1. Right? So from here, I can find out VD1. So the VD1 that will be equal to I1 by A1. And I is also constant. I is also constant. Current is also constant everywhere. So I can say VD1 is inversely proportional to A1. Likewise, here we can say VD2 that will be inversely proportional to 1 by A2. This is my equation 1, this is my equation 2. Now divide 1 by 2. If I divide equation 1 by equation 2, 1 by 2, so what I will get? VD1 by VD2 that will be equal to A2 by A1. Right? So VD1 is given, A1 is given, A2 is given. We need to calculate VD2. Just cross multiply. So cross multiply. So VD2 that will be VD2 into A2 that will be equal to VD1 into A1. So I will calculate VD2 equal to VD1 A1 divided by A2, right? So VD2 is equal to VD1 2.2 multiply 10 to power minus 4. 2.2 multiply 10 to power minus 4. Multiply A1, this is A1, this is A1. 3.14 multiply 0.5 multiply 0.5 0.25 multiply 10 to power minus 6 divide by this whole divide by A2. 3.14 multiply 10 to power minus 6. Now 10 to power minus 6 is cancelled. Okay, 3.4 is cancelled. Right? So VD2 that will be equal to, now multiply 2.2 by 0.25. 2.2 0.25. 2.2 multiply 0.25. 0.55 multiply 10 to power minus 4. So this can be written as VD2 is equal to 5.5 multiply 10 to power minus 5 meter per second. So the drift speed VD2 that will be equal to 5.5 multiply 10 to power minus 5 meter per second. So the drift speed here is 2.2 multiply 10 to power minus 4. So which is greater, VD1 or VD2? At which point the drift speed is more? This means when the numbers are negative, so it means VD1 is greater than VD2. VD1 is greater than VD2. Right? So VD1 is greater than VD2. This is also expected, right? Because the drift speed that is inversely proportional to the drift speed is inversely proportional to the area. Where is the formula? Yeah, drift speed is inversely proportional to the lesser is the area, more is the drift speed. So you see, this is the less area, so more drift speed. So VD1 that will be equal to VD2. Okay.